Hello CS111 students. This is my problem set video for problem set 2, task 1, the Time Profiler Deluxe. And just as a reminder, these videos are just me reading through what's in the problem set description. You can go read it yourself. You do not have to watch these videos if you don't want to. Time Profiler Deluxe is a revisit of the Time Profiler task from problem set 1. And your goal will be to basically do most of the same things with a few extra bells and whistles using functions. So defining your own custom functions along the way. So the overall goal is to, like I said, do almost the same thing as the time profiler. Ask some questions about how much time the user spends on various tasks, prints out a report about their time per week, and there's a few differences from the original task in terms of the output. So one of them is very minor, just that the prompt for the number of classes that you're taking must accept floating point numbers like 2.5 as input, not just integers. So that's a minor difference, and then a slightly larger difference is the printed output will be fancier, and I'll go into the details in a second, but in addition to printing out the rounded hours per week values for each category, it's going to print a bar of letters. So the same letter repeated a bunch of times to make a sort of bar as a visual indication of how much time that number is. And so you can compare the bars and sort of see how things stack up between the different categories. To do that, to make the bars comparable, we'll also have to do some alignment of the text. And again, I'll get into what that looks like in a second. So, as I also said, in addition to these differences in the input-output, we're requiring that in this version of the task, you use your own custom functions. But we're giving you a lot of freedom to design them. There's a few restrictions, but a lot of freedom. You are welcome to reuse the code from your original submission of the time profiler. A lot of that code is still relevant. But you may have to reorganize some of it and move it into functions in order to satisfy the rubric for this task. So do check out the task rubric as well for specific requirements. But here are the requirements for what kind of functions you have to define. So overall, you have to define a function called main that has no parameters. And when you call it, it creates the whole input-output pattern of behavior that your whole program did in the previous task. So in the previous task, you wrote a program. When you run the program, all this stuff happens. In the new task, when you run your program, nothing's going to happen unless you call the main function. And when you call the main function, all the stuff that happened last time will happen. All the inputs, all the outputs after those inputs. Now, the code that we've given you as starter code has a test function that calls the main function when you run the program. So it'll still actually produce the same output when you run it, just sort of in a roundabout way. So what does the main function need to do? It must use at least 4 distinct custom functions. You can use more if you want, but there have to be at least 4 of them, and they have to have different names. Counting all uses of those custom functions, including times where you may use the same function in more than one place. That's one of the powers of functions, is using the same function again and again, because you have to do similar work. You must have at least 10 function calls to custom functions from within that main function. So 4 is the number of different functions you need, and then 10 is the number of places where you need to call those functions. So, as an example, you could have 4 custom functions, and you call 3 of them 1 time each, and then the last one you call 7 times. That's 4 custom functions and 10 function calls. There's obviously many, many different ways. You could have 4 custom functions, call them each twice, that would be 8, and call the last one an extra 2 times, that would be 10. All right. What else about the main function? So you must not call the input function in your main function itself. Now, obviously, you have to call input a specific number of times, 6, to satisfy the requirements. So you're going to need to use a custom function to do so. And in fact, at least one of your custom functions has to call input, and that function must also use a return statement to return a value. You'll find that using a return statement in the function that calls input is going to be necessary anyway to move the information around to get it to the place it needs to go. Because again, variables defined in one function are local to that function. Other functions cannot reference them, but a return is the way to move that information where it needs to go. So, at least one of your custom functions, could be more than one, needs to call the input function and return. Your main function is not allowed to call input at all. And then there's a few different requirements here because we want you to have a variety of functions. We want you to think about design and what's the best place to use a function that does this or that. So of your, again, 4 custom functions at minimum, at least one must have 0 parameters. At least one must have 2 or more parameters. And at least one of your custom functions must have at least one parameter and also use return, right? The main function itself must not use return. There's no point for it to do that. It doesn't have anything to say to the rest of the program. It's sort of a self-contained full thing. And then the main function must call print in at least one place. And as an extra goal, it should call print in no more than 6 places. And this time that includes any time print appears in any of your custom functions. So that's basically saying the total times that print should appear in your whole program is no more than 6 for that extra goal, excluding the prints that we have in the testing code. So it's possible for one of your custom functions to fulfill multiple requirements from the list above, excluding the first 2 about how many there should be. So, for example, when we say, hey, one of your custom functions needs to call input and must use return. That could also be the function that has at least one parameter and uses return, right? If a function has a parameter and uses input and uses return, it checks off both of those boxes. So you can treat these requirements as boxes you need to check. You can check multiple boxes based on one function. Obviously, there are some that are exclusive. You can't have a function that has 2 or more parameters and also has 0 parameters. But as long as you check all the boxes across all the custom functions you define, you're good. And if you just want to do it in a very straightforward way, you could, define one function for each of these things to make sure you have them covered, but that's not necessary. So we've given you some constraints, and we hope that these constraints are productive, that they give you a few hints about how to approach this, because it is a very open-ended task, right? Achieve the same thing you did last week, but using custom functions. We hope that this will give you some good practice with custom functions and with thinking about how to design where to use functions, right? If you look at your original code, look for maybe, where's a place that I'm repeating the same kind of code again and again and again? Is that an opportunity where I could define a function and then call that function multiple times without having to repeat a big block of code? Okay. So we're giving you some behavior examples, just like we did last time, of what this should look like when you run it. And again, like last time, the text in blue indicates what the user is typing in this hypothetical scenario. You're going to be responsible for typing things when you run the program. But if you type in these same inputs, you should get the exact same output. And just like last time, things like the ordering is super important because we're going to test these automatically. So I'm not going to go into the details of these examples too much, except to talk about the structure of the output at the end. The other thing I will note is that each of these examples was produced by taking our solution code and running the main function, right? Just a reminder that the main function is going to do all the inputs, all the printing within itself. And that's going to be called when we run the program because of our test function. So you'll notice that these are the same names and example numbers that we used last week mostly, with the addition of Nira. Look at the bottom part here where it talks about the weekly time profiler for whoever it is. Before, we would have just said, oh, so-and-so many class hours, so-and-so many whatever hours, so-and-so many sleep hours, so-and-so many free hours, done. That was what we did on task 3 of problem set 1. So what we're doing now is we have the same messages. a number rounded to 2 decimal places, or fewer if it naturally has fewer. A sort of category name, which is class, or our custom category, or sleep, or free. The word hours. And then there's a colon that didn't used to be there. And we've added spaces beforehand so that each of these colons lines up. Whatever message is the longest, for example, in Valentina's case, rock climbing is a very long custom class or custom category name, so 28.0 rock climbing hours turns out to be the longest. That one has 0 spaces before it. And getting it to be 0 is going to be tricky. And the other ones have extra spaces so that their colons all line up. And that's an extra part of this task that you'll have to figure out. But that's a great place to use some custom functions to figure that out. And then after the colon, there's a single space. And then a certain letter repeated a bunch of times. For class, it's the letter C. For the custom category, it's the letter X. For sleep, it's the letter S. And for free, it's the letter F. Those letters are always the same no matter what the custom category is or whatever else is going on. Now, the number of copies of the letter is the number beforehand rounded to an integer. So you can see in these different time profiles that there's different numbers that we get based on all the computations, same kind of computations we did last week. And we round those numbers to an integer, and we get that many copies of that letter. Something I'm going to point out here is that in this last example, you can see 37.2 class hours, 37.0 Zoom recovery hours, 37.8 free hours. Notice there's one extra F compared to the numbers of C's and X's. That's because 37.2 and 37.0 rounded down to 37. 37.8 rounds up to 38. All right. So as we mentioned last week, there's a difference checker website you can use to inspect your output. I've had a report from one student that it was asking them to pay for it or log in. You do not need to log in. You do not need to pay to use this tool. It should link you to a place where you can just paste in text. And if it's asking you to pay or something, there should be a way to just send that message away. But that tool can be used to check for detailed differences in the text. And if you looked at your feedback from problem set 1, you might have seen that you may not have gotten everything exactly right the way we wanted it. So the difference checker is useful. And then one last requirement for our testing. So we've given you starter code that has a test function in it. And that test function calls your main function. You might want to test the other functions you're defining on their own before you try to put everything together. To do that, you can modify the code in the test function. And this is a pattern going forward that when we give you a test function, you can put whatever you want in there. It's not graded. It doesn't matter as long as it doesn't cause an error. However, you're not allowed to put any code outside of functions that might run when you click the run button, besides what's in the test. So anything in the test, that code will run when you click the run button. Put whatever you want in there. Don't put anything outside of the test function or outside of other functions, like a call to your main function so that it'll run when you run the file. Put that stuff in your test function. And this is just a setup so that the automatic grader doesn't get confused. If you end up putting code outside of your their functions, there's a goal for that you will get points off for. And you might get a lot of more points off if that causes our testing script to crash. If that's the case, simply submit a revision that sort of fixes that issue. So that's all I have to say about this task. Again, it's revisiting a previous task, but this time with custom functions, which is what we're learning about this week. Hope that all makes sense.